it is a great pleasure to have you, and please take it away. And you know, we're looking forward to the conversation.
Thanks so much, Shane, for the invitation. It's a pleasure to be here. I mean, even if it's at home, I would of course prefer to come to Boston. But it's really great to present this paper in this audience. So this is joint work with Jörg Clausen, who's in Munich, and Ananya Sen, who's at CMU, and also on the call. So Ananya will help me with all the very difficult questions. So what we want to do in this paper is we run a field experiment in the context of online news. And we're interested to study the effects of algorithmic recommendation on user behavior. And in that context, we are going to look very closely at what is the value of data, different kinds of data, personal data, social data, sort of how do you compare in your preferences against others, and so on. So let me start with the big picture. So I guess in this crowd, I don't have to mention that digitization has disrupted and led to innovation in a variety of industries, and sort of moving along, AI and particularly machine learning technologies are expected to play an increasingly important role. And of course, in machine learning, data is a critical factor. And therefore, we can think of data as really being key to enable innovation and productivity gains. And of course, the news industry is a prime example for these two things at the same time, where we know that the newspapers have been disrupted quite a bit by digitization, where a lot of the revenues, especially from classified ads, have been gone away. People have almost completely moved from reading print newspapers to online newspapers. So there's been quite a change in that industry. But then at the same time, while making that transformation, there's also a huge potential to increase the revenues due to personalization and actually use the data that is now available, given that the industry has almost completely moved online. And so in this paper, what we want to do is we want to understand how personalization plays out in the context of the news industry, and we're going to do that by running a field experiment with the major news outlet in Germany that will allow us to sort of get at causal estimates of comparison that we're making between a human editor and a recommendation algorithm. And given the size of this experiment, we're going to have a lot of variation, not only across users, but also over time, that will allow us to really characterize the returns to data along a variety of dimensions, not only amount of data, but also different types of data. So what is the industry background here? So there's been a debate in the news industry whether human editorial decisions should be aided or replaced by algorithmic recommendations, which can personalize at scale. And so sort of the current approach in the industry is that there's a human editor that sort of selects what makes it to the front page, or even in the old days, there was always some kind of mechanism that decided on what are the news of the day, because of course there's always more news than what fits into one print issue. And it's been reported that social media platforms and also news aggregators have struggled to find a fully automated system that kind of works flawlessly. And then it turns out that human editorial decisions are actually crucial for reader engagement. That's at least what we know from sort of casually following this debate that you can observe in the news itself. And then the second sort of piece of industry background that I want to share is that even the major news outlets have just recently started to experiment with personalized recommendations and sort of use data and algorithms to, at least to some extent, replace the human curation process. And so in our setting, we think that we are very fortunate to be working with an industry partner that is sort of at the forefront of experimentation with these technologies. Now, why is it interesting to study news, that particular setting of news, when we want to think about sort of the more broader aspects of what's the value of data, what are circumstances under which data creates value? It's because news has this creative and subjective production, but in our case, more interesting, the curation processes, where it's not necessarily clear how you would replace that human element of creativity by a machine, and how you would design an algorithm that can do that. So we think it's an interesting setting to study this sort of man versus machine kind of aspects. The second reason why we think that news is an interesting setting to study the value of data, it's because it's a fast-moving industry where timing is really critical. So in this paper by Julia Cagé and others, they show that it takes less than a couple of minutes for news stories to be copied across different outlets. So on the supply side, it's clear that this is an industry that's really fast-moving and timing is critical. But then on the demand side as well, consumer preferences might change dynamically, and people might be interested in different things at different points in time, and that might be difficult to predict for a machine learning algorithm, which leaves some scope for human judgment. So there's these two elements where we think that there could be scope for humans being involved and creating value. That's first this creative, subjective part, and then also the part where it's fast moving, things change all the time, and humans might have an edge over certain kinds of machine learning algorithms.
Christian?
And so, yes.
Christian, hi. I think there's other situations in which the human may have an edge, which is sort of the value of the news being shared, right? So, the machine learning algorithm may be very good at predicting that I like fashion articles, but for me, it may be more useful to learn about politics or the economy. And that's where the human really can play a role.
Yes, so that's
and understand the trade-off a bit better.
Yes, absolutely. So that's a very good point. So for most of the things that we're concerned with in this paper, we care about maximizing clicks. And it's not necessarily clear whether that's also the social optimum, right? So there might be like welfare benefits for people being more informed, that's such that they can make better informed decisions in elections and so on. And so you're right that there could be actually that's something that might be also this kind of objective function might be relatively difficult to replicate in a machine learning algorithm. And some aspects of this are in our paper as well, because we are looking at the comparison between human curation and the recommendation algorithms. And so you can think of this as a feature and a bug at the same time. So it's the feature that the humans might have a different objective function, and so we're capturing this human element. But at the same time, it could also be a bug because it's not we don't have a very good way of knowing what exactly the objective function of the editors are, and so we have some evidence that suggests that they do also care quite a bit about clicks, especially in our setting, because it's an outlet that is mostly advertising funded, and so clicks are really income that pays the wages and the bills of the people, the editors that work for the outlet. But we don't really know what the objective function is. But I think it's
got it. But it's not a subscription newspaper then, like the New York Times?
No.
Okay.
No, they
Thanks.
don't
That's very
have a paywall at all. Yeah.
Great. Thanks.
Can I follow up a little bit?
Of course.
I mean, I know you're going to set this up in such a way as to have a clean, comparison between human and algorithm, but and that's good. What worries me a bit in the same league as Chiara's question is headlines. So, there's a lot of creativity that goes into making a headline, and in some sense, what a headline is for maximizing clicks isn't necessarily going to be the same headline for maximizing conveying information. And even though I know you're going to set up the experiment to try to hold that constant, there's a part of me that says, well, that's going to be endogenous to whether the writers know they are either going to have human curation or algorithmic curation, because once you know it's algorithmic, the headline writers and the story writers will write it in such a way as to fit into the algorithm. And so I know you can, in some sense, control for that endogeneity, but there's a sense in which, in some sense, you also want to know about that also. So that you see the question I'm asking.
Yes. So you're right that in our setting, this shouldn't matter at all, because we're basically only looking at the curation part and not at the production part. So everything is still produced by human journalists. The human journalists don't even know that this experiment is running.
Oh, is that, okay. Well,
and so it cannot be that they're making things more clickbaity or not, whatever their considerations might be. But looking further ahead, of course, once you would also use these technologies more on the production side, and you would now we have these very fancy text generation AI tools. You could easily see how a machine could also do that and then sort of respond to people's preferences. And I mean, there's some anecdotal evidence that actually on YouTube, people have figured out what works best in terms of clicks. And then there's fully automated like kids videos that put together all kinds of crazy combinations of keywords that lead to a lot of clicks on YouTube. And then you get also various kinds of weird things that are just a direct response to how the recommendation algorithm at YouTube works.
Yes, I have read about those also. So in some sense, I was inspired by those.
But I don't think that's an issue at all in our setting.
Okay.
All right. So what are the questions that we want to attempt to answer here? So first, what are the economic returns to data as compared to sort of what you might have in mind as the statistical returns to data? So we're looking at sort of not only how well does the algorithm perform in an sort of when you would compare like a test sample versus a training sample, but we're looking at actually the another layer where we do with this experiment we can actually see people's reactions also to seeing the recommendations, which are two separate things to some extent. And then what's the role of personal versus aggregate data, which might be interesting also from a policy perspective, because many privacy regulations are targeted at personal data, and regulations are much less strict about aggregate data once you can no longer identify individual people in the data. And then we're also going to look at the question of how does personalization affect news consumption, which to some extent goes back to sort of the notion that Chiara raised in her question. Do people, basically the question that we're asking here is, do people change their reading behavior because of these recommendations? Do they read other stuff? And then maybe stuff that from a social perspective, they should read less. And then in the paper, I wouldn't have time to talk about that much today. We're also sort of trying to understand a little bit more who, what are the characteristics of people that respond, especially to algorithmic recommendations, in order to speak a little bit to this debate that has been, of interest to media economics people for quite some time now, about echo chambers and polarization and these kinds of things. But I won't talk about this today. Okay, so quick preview of the results. What are the economic returns to data? We're going to find that on average, personalization increases clicks by about 4%, but we see diminishing returns. Actually, more data helps to increase clicks quite a bit, but then at some point, once adding more data doesn't help much more. And that's interesting because, you would expect something like that to happen just from a statistics point of view. At some point, adding more data points to your sample doesn't affect the precision of your estimates anymore. But it's not so clear from the current policy debate, where people tend to think that big companies are so big because they have so much data, and the more data they have, the bigger they get. And so, at least in this setting, we can show that there's actually diminishing returns to this personal data. And we also show that a flow of fresh data is important, and that's might be specific to our setting, where I said that the news industry is fast moving and so on. And so once you don't have a continuous updating of people's click behavior, you're not as good in following their preferences anymore, and then your returns to the personalization technology also decrease. And that might not only be an issue in the news industry, but in many fast-moving industries like finance, like search, for example, where people continuously feed new data and sort of have changing preferences dynamically.
Christian?
Hi, Hong. Good to see you.
Yeah, I was eating, so I was really off screen. So you're probably going to talk about this, but conceptually, theoretically at least, it's possible to not only just look at have diminishing return, but actually negative return, right? In terms of having more data, having greater tailorization. Okay.
Yes. So I'll have a little bit about that later on, where we have some results on data network effects, and I'm going to show you. Actually, I can show you this right away. I'm going to show you that the effect of adding additional aggregate data increases with the user base, but only if the user base is actually sufficiently homogeneous. If the new users that you add have very similar preferences as the users that you already have on a platform. And so in that sense, you can actually sort of shift the point where the diminishing returns increase slightly to the right. But on overall, we actually see these diminishing returns. I'm not sure whether that answers your question, though.
Yeah, I was thinking about sort of the first example I thought about was like Amazon recommending like things that I've already purchased, right? Like, or movies that I've already watched. But of course, like, I'm less likely to do that. And similar for news, probably too. It's like if you further narrow down my specific taste, either because of lack of novelty or some other issues, that it may hurt my click rate rather than just not as helpful.
Yeah. So I don't think I have a good answer to this right now, but maybe we can get back to your question later once I showed you more details of the results, and then I have an idea on how it would on how our results could connect to your question, but I think we need more context for that. Okay, so let me go back. So we're asking what's the role of personal versus aggregate data, and one of the key findings here will be that personal data is key to realize the gains from the algorithm. And then the story about the local data network effects that I already briefly mentioned. And then regarding our third research question, how does personalization affect demand patterns? We'll see that people that are treated, that basically see these recommendations, they reduce the diversity, so they basically sort of get pushed into a rabbit hole and keep consuming stuff of similar type. And this effect is reinforced over time as you come back more often to the website, as you get more personalized recommendations. You're pushed further down into the rabbit hole. Okay, so let me talk a little bit about our contribution to the literature. So there are a few empirical studies on scale effects in data, and what's interesting about these studies is that they point into different directions. So this paper by Leslie and Catherine, they look at search engines and different data retention policies across different countries, which sort of serves as an exogenous shock to how much data can a search engine use, and then look at and find that more data helps to increase the quality of the search results. Then there's this paper that looks at internal data at Amazon, where they look at different prediction technologies for predicting demand, where there are also some positive scale effects. And then there's this other paper that also looks into search engines and finds the opposite. So what's common to these papers? They're all super interesting papers, but we think that we can identify the effects slightly better because we have this experimental variation, and that just gives us much more traction on really identifying the dynamic dynamic effects here. And then this, of course, also speaks to this recent theoretical literature and this whole debate about data network effects. And then, of course, people in computer science have long evaluated recommender systems, but that's typically what they typically do in computer science is what they call an offline evaluation, which is basically horse races of different kinds of algorithms against each other on a training sample, then a test sample. But what we are doing here is we're basically looking at the performance of a recommendation algorithm in the wild, and sort of adding the social science piece to it, the human reactions to the human behavior, consumer behavior. All right. Let me pause here, see if there are some further questions. If not, then let me get into the empirical setting. So we're working with the large German news outlet. It's you can think of it as like in the top 3 of the German newspapers, 20 million visitors per month. And as we already discussed, its income is mostly coming from advertising revenues. So clicks are really important. They don't have any paywall, no subscription service whatsoever. And the way this outlet is running is that they the homepage is curated by a set of human editors. Of course, so of course the news cycle on a particular day is longer than a regular shift in in a highly regulated German work highly the German work regulations would require people to not work as long as a news day is, and so we'll see several people actually curating the homepage. We don't know exactly which human editor is curating the homepage at a given point in time, but what we can of course do is we can throw in a bunch of time fixed effects to control for the fact that some human editors might be different than others. And so that's the way the website works. A user that arrives at the homepage sees the same content. So if you and I visit the website right now at the same point in time, we get exactly the same the same layout. And this is changed in our experiment, which yes.
Yeah, a question. I think you'll understand the point that what type of advertising are we talking about? Is it impression or is it click-through?
Good question. I think it's a mix. They have all kinds of different ads. They have they also have these these recommended stories that actually put you to other news outlets. But I don't know the exact. So and
you know why I'm asking, right? Because
yeah, of course, yes.
Right, because if it's just if the incentive is just to generate a reader, that's a question. But if the incentive is to tailor to a particular reader, then clicking through matters quite a bit more. Yeah.
So I don't have a good answer to this. We tried to actually get data on the actual revenues of the newspaper, but they wouldn't give us this data. Sure. And so on the business side, they were not very open. So we could only talk to the data people. But on the business side, we don't know. But my guess would be that they have a mixture of impressions and click through.
This also, it's interesting. It also affects the way I think about your 4%. So, right. So 4% didn't sound like very much when you said it, but then now I'm thinking, but 4% in the face of a personalized ad is actually quite a lot. So.
Yeah. So I'll have a back of the envelope calculation on what 4% means in dollar units, which makes a couple of wild assumptions, including that everything is click through. Because that's where we sort of have public information about what is a click worth and so on. But in reality, it's probably a mix. But I simply don't know.
Yeah, you got it.
Okay, so so our experiment ran for quite some time, from December 17 to April 18, which gives us a lot of variation also across the news cycle and different kinds of events that happened. And also a lot of users, of course, that arrive at the website. So now, how does the experimental setting look like? So every time a user arrives at the homepage, she is randomly assigned to a control or treatment condition. And then in the control group, everything is just as always. The user sees all the articles on the homepage as curated by a human editor. And then in the treatment group, the user sees a customized layout where the algorithm can override one slot in the human editor's ranking. So what it's essentially doing is it's reshuffling the ordering of the articles that the human editor has decided. So it can only pick from all the articles that are in a given day are somewhat listed on the homepage, and then it's just reshuffling one slot. So it's a fairly small experiment. It's just changing slot number 4 and can change slot number 4. So in this example, we would think that that user would be more interested in the category of Article 6, and so Article 6 would be moved up. And then accordingly, the rest of the ranking would stay in the same order, but be changed slightly.
Christian, can you tell us a little bit about the algorithm? What I'm assuming it's trying to maximize click-through rates. But is this an online algorithm? Does it keep on learning? Does it have some experimentation built in it?
Yeah, so I'll do that right away.
Okay,
so it's the goal of the algorithm is to maximize clicks of treated users. You can think of this as kind of like a naive Bayes with bells and whistles. It's based on what they used to have at Google News. So what the data science team is doing is they've looked at this paper here, which is fairly well cited, and sort of applied it to the context of that news outlet. And so the way you can think about this is it's basically a combination of what they call the what you see on Amazon based on your previous purchasing history. Because you bought a book on causal inference, you might be interested in that econometrics book. So that's based on personal data. And then the other part, the other types of recommendations that we also spoke about today already are the ones where people who have bought this also bought that. And that's the sort of the, computer science, they call this the collaborative filtering approach. So that's the sort of this where the algorithm gives you recommendations based on social data about other people's preferences. And so with that, the model tries to sort of predict user preferences on a category level. And then it sort of once it has found your favorite category, then it will look for, are there any articles on the homepage in that given moment that fit your favorite category most, and then it's going to pull that article up. So if it thinks that I'm more, say article 4 is politics, but it thinks that I'm more interested in sports and article 6 is a sports article, then it would move article 6 up.
The question, why didn't, I suspect, and you can confirm this, that the newspaper permitted you to do this because it sort of limits the downside. On the other hand, I could have imagined a different experiment using this algorithm, which would have been to introduce an article onto the front page and remove one, equally incremental, right? In the sense, but to introduce one that was tailored to this person's preferences. But they preferred this method because it was, I say, limits the downside in some sense, or
I think that's the reason. The other reason, the other thing that limits the downsides is that we were not allowed to play around with the top slots and only slot number 4. So they were very careful in sort of the cost of the experiment, and this was the first in a series of experiments that they ran. And later on, they also went more wild and played around with the entire ranking. And then they also allowed the algorithm to pick any article from the back catalog. So it would also be able not only to pick articles that a human editor has decided to be important enough for today to be on the front page, but it could also pull stuff from,
which is what I
from
had
the past.
And just I didn't ask this at the time, but there's no information given to the user that they're looking at an article that everybody else looked at. No. It
looks exactly the same. And there's actually quite some, go to any news outlet and refresh the page after 5 minutes, after 10 minutes and so on. You'll see that there's lots of movement, and also even if it's completely human curated, they're playing around with the rankings all the time. They also have a dashboard where they see how articles are performing and so on. And so if you thought that, this looks weird, why am I getting a sports article already on slot 4? Usually it's way further down, and you would refresh, then it would be basically impossible for you to figure out, because things might have changed anyways.
So I also see now some use these popular today or popular right now, which is a way of telling you, and then they rank, in order. They don't tell you how popular, they just put them in order. And that's a way of telling you what other people are looking at. And that can influence your taste also. But if that's not being shown here, that's fine. It's in some sense cleaner. Yeah.
Yeah. So it's there's no way to figure out, and especially if you refresh, then you're again randomly assigned to treatment and control. So there's again a 50% chance that you see the human curated version. Okay. So let me talk about the empirical strategy. So the nice thing about experiments is that the econometrics become very easy. So this is just a linear model with fixed effects. So we're looking at clicks as the outcome, and then we're looking at the difference between the treatment users in the treatment group and users in the control group. And what's really important here is that the unit of observation is user session. So every time you refresh and go back to the landing page, you are again assigned to treatment or control. And that's going to be very helpful for us because it allows us to also put user fixed effects and see the same person, the same cookie ID, sometimes in the treatment group and sometimes in the control group. So for most of the cases, I think that cookie ID and person is synonymous, but some people might delete their cookies, and so it's not necessarily clear that these are really different individuals. So every time I say user, keep in mind that I actually should say cookie. And so with the user fixed effects, we can actually then compare the same person in a treatment group and in the control group to do all these things that we already talked about, like how does my behavior change when I see the recommendations versus how does my behavior change when I don't see the recommendations. And so it's giving us a nice experimental angle to play with. And then, of course, we have all kinds of time-fixed effects at various fine-grained levels. And there are a bunch of robustness checks in the paper on this. But mostly, of course, we want to control for the fact that some news days are just more interesting than others. And depending on the time of the day, the layout might look differently appealing to you, and so on. So all these things that are time varying, we can capture with that, as long as they're fixed to all users. All right, so this is what you get if you run this simple model with the day fixed effects, user fixed effects. You get a coefficient that looks like this, and if you compare this against the mean, then you end up with this 4% effect size that we already talked about. Now, it turns out that this hides quite a bit of heterogeneity. And so one way to look at this is to look at the number of data points that the algorithm has about you. And so the way we do this is we're just measuring how often did you come back to the website. So how many visits did you have? Because of course every time a user visits, that's new data that will be fed into the algorithm. And so the most naive way to do this is, of course, to just 1 second, Kira, is to have this linear interaction. And then you already see that as you add more data points, sort of the click-through rates increase. Kiara.
Yes, where do these prior visits come from? Do they come from like pre-experimental period or during the experimental period? Because if they come from the experimental period, aren't you worried that they may be affected by the treatment?
Yes, so we can do both. So we also have clicks of users before the experiment. In some of the things that I will show you, we are actually only using the before period to be absolutely sure that people's preferences have not been influenced by the algorithm. Here in this case, we tend to think that it's actually interesting to see how sort of the behavior changes as you get exposed to the recommendations over time, because here we are basically what we want to do is we want to compare the same user sometimes in the treatment group, sometimes in the control group, depending on how often they come back. And so with the user fixed effect, we everything that's time invariant should be conditioned out. But yeah, I see your point.
But here's what I'm worried about, right? Like, so let's assume that the treatment is very good for certain people and very bad for other people, right? So you would have, and to the point that it makes certain people come back at higher rates, and the ones that don't like the treatment just disappear, right? So you would have this selected sample of individuals who have more prior visits for which the treatment has particularly worked, compared to users for which you don't have as many visits, but that's because the treatment sucked for them, and so they abandoned the site.
Yeah. So yes. So
I think one thing that you would want to check is whether prior visit is predicted by the treatment.
Yes. And I don't think it is, because so if I remember correctly, that's one of the things we did. I don't have it on the slides, but we looked at that. It's also if I remember correctly, then also your probability of coming back doesn't change when you're exposed to the treatment, which should also be sort of the same, go into the same direction. But I'm not 100% sure about this. It's been a while since I looked into the data.
But you see my worry, right?
I see it, yes. And
yeah, okay.
My other response would be if these are like inherent characteristics of users, and so you are just the type that responds more to recommendations, and that doesn't vary over time, then the user fixed effects should also take care of that, I guess.
If they are invariant, I agree. But
yeah.
to the extent that, anyway, you see my point.
Yes, I see it. Yes. I'm sorry that I don't have a better answer. Don't have a fresh memory of the
no problem. It's just that I've seen the paper enough that now I can get really mean sometimes. Sorry.
Well, I think actually the way I totally agree with what Chiara said, but I'll say it a slightly different way. Right? She's emphasizing the validity of the internal validity of the experiment. But for the purposes of the newspaper, right, it would be really alarming to them if you found that reordering the presentation of stories altered the frequency with which readers came back. I'm saying it, or the speed with which they came back. So I'm trying to say this in an extreme way, right? So it not only does it matter for the internal validity of the experiment, which I think is exactly right, but let's say it did matter, okay? And let's consider the extreme. Oh my God, right? That's a finding. Now, I'd be amazed if you actually got that finding, given how mild the changes you're making are. But on the other hand, right, that for the purposes of the newspaper, they'd be alarmed to find out that if they lost readers because of just a reshuffling, or maybe the other way around, mere reshuffling got people to show up, more often.
I mean, what we find is that people also are more active on the website, so they also click more on articles in general, and so that's mostly coming from them reading something that they find interesting, and then clicking on the follow-up links that are in there, and that's a function of just finding stuff that's more interesting to you, and then you sort of dig deeper, I guess, rather than wow, this website is just so much more useful since now on slot number 4 I get more interesting stuff.
But eventually, sorry to hone on this topic, but eventually you would want the algorithm to bring your users back more frequently, right? So that should be one of your outcomes of interest. It's not just the click conditional on you showing up, but also the probability that you show up altogether. So I would think that is a super interesting outcome of interest that you can even look at. because I think you have the perfect experiment to look at that.
Yes. Yeah, we definitely can do that. And, if my memory serves me right, we did that, and then we didn't find anything, and then we decided we already have so many other things in the paper. So, but yeah, maybe Ananya knows more about this. Has a better memory. Okay, so let me show you this picture. This is basically a non-parametric version of the second column in the table that I just showed you. So what we're doing here is we're slicing the data into different bins according to the percentiles of prior visits. So here we call it user data, but as a user comes back more often, they provide more data to the algorithm. So you can think of this as more data. And so what you see is that there is this period where actually the algorithm underperforms the human curated version, and then at some point it continues to outperform, and sort of people click more when in the treatment group compared to when in the control group. But this really immense increase here flattens out quite substantially, and that's the idea of the decreasing returns that I was emphasizing earlier. So now you might wonder, what does this 35th percentile imply in terms of visits? That's about 3 visits. So a lot of people, so 35% or so, only come back to the website 3 times in our observation period. And then of course you get people that click like crazy in the higher end of the distribution. And so what this means is, if the algorithm has relatively little information about your preferences because you show up so little, then it actually recommends you stuff that you're less interested in according to what the editor has put there. Or one interpretation would be maybe the human editor is better at sort of predicting like the average user's preferences. And so now in terms of effect sizes, if you sort of compare these coefficients to the means, then you end up with like a drastic decrease. This is like 30% less, and here it's like 20% more. So this 4% number that I gave you really hides a lot of heterogeneity. Nevertheless, I want to spend a little bit of time sort of giving you a back of the envelope calculation, which of course has lots of problems. One, it's partial equilibrium. Second, it's based on wild assumptions. But let's just for the sake of sort of getting a better feeling what this 4% means. So 4% is 4.5 million clicks more, because our outlet has 120 million. So this should actually be that's 3.75. So that's okay. And then back to our discussion, Shane, about click-through rates. So, if you look at the publicly available, like in advertising industry numbers that are out there, then average click-through rate is 0.35%. So this means 15 or 16K monthly clicks more. And then, let's make another wild assumption. Each page has 2 prominent ads, which is probably wrong. They have more ads than that, but let's be conservative. Then cost per click, again, according to industry numbers that we could find, is about 60 cents. And so you get at around 18K additional monthly revenue. So what are the costs? The salary of a data scientist, including social expenditures and so on in Germany, is like 7K. And so you need about 50 million clicks to break even. And what does 50 million mean? So if you want to compare this to the US media market, here are some outlets and sort of the clicks that they have. So it looks like it's that's an operation that they should do more. And this is a very this is a very subtle experiment. So we're only looking at slot number 4. We're just changing the ranking. We're not even doing any crazy things. Okay, so now let's talk a little bit about stock versus flow. And why is it?
Could I
yes.
ask, or you can
yes, of course.
Defer this question to later if you want to. You know, you could show these numbers to the editorial team and the publishing team at your newspaper, and you'd still might get resistance because they're worried about a revolt in the newsroom. I mean, did you, or some other organizational resistance? You can defer this to later, but I would imagine, knowing, news organizations for what they are, they really don't like this idea at all.
Yeah, so it was actually funny because we always wanted to get more data on the revenue side. We wanted to have information about who are the editors, such that we can put editor fixed effects and so on. And our contacts in the data science team, they said, no, there's a Chinese wall between us and the journalists. The journalists don't know what we're doing here. We are on a completely different mission than the journalists. And actually, to the other extreme, so when they internally looked at the results of the experiment, they didn't put the user fixed effects. And so what they got was basically, if you just look at the average without user fixed effects, then of course these guys here have a pretty big weight in the average. So if you're just comparing basically treatment group versus control group, you end up with a negative estimate on average. If you don't control for the fact that this user heterogeneity in there, in how often people come back. And so what the data science team did was they were like, okay, let's stop this immediately. We're burning cash, and they didn't want to talk about it anymore. And then at some point they decided, okay, let's run more experiments and so on. And we like to think that they were inspired, because of course we also gave a quick presentation about our findings, and like to think that they were inspired to sort of dig deeper a little bit. But this concept of user fixed effects and heterogeneity was fairly weird to them.
That's quite a war story. Oh my goodness.
Christian, I have a quick question. There is sort of my ignorance about these literature. What's the relationship between? So my understanding is that the advertising rate may be just simply based on clicks, rather than differentiating whether this 10 clicks comes from one person versus this 10 clicks comes from 10 people, right? But then from a consumption capacity point of view, it does seem to matter. So how many goods can one person buy versus how many goods can 10 people buy? So in that case, whether using user fixed effects or whether changing advertising rate to be a function of uniqueness of the user seem to be relevant.
Yes, so that's a great question. So which I guess relates to Shane's earlier question, whether they get paid by people clicking or they get paid by people looking at ads. And so again, I guess, so I'll have to be very hand wavy again on this question. I'm sorry, Hong, you have great questions. I always have very bad answers. So probably it's a mixture of remuneration models that they have, and some ads might actually be also personalized, which tend to be much more expensive. And therefore, quite the opposite of what you're describing, where although there are just a few clicks, that these clicks are really a moneymaker for the outlet. But I wish I had a better answer.
No, I think it's just a more general question, right? It probably doesn't really matter for your particular, but then it does matter when you actually do back of envelope.
Yes,
calculation in terms of how to think about the ultimate money.
Yes, no, I agree.
And so in some sense, maybe the entire advertising industry is not really adjusting for that fact yet, depending on sort of the data precision relationship between data precision and purchasing profitability.
Yeah, I agree. Let me think more about that. Okay, stock versus flow. So this this dimension of stock versus flow is important because it has the strategic importance. When a visit to the website creates a flow of data that sort of accumulates over time to a stock, then this might be basically an entry barrier. So if stocks are more important than flows, then once you are a big website that has a big stock, then sort of you have a competitive edge over an entrant. But if flow is more important, then sort of size shouldn't matter that much. And that's why we're looking at this. The real reason why we're looking at this is because Chiara had recommended to do that like many years ago, when like sort of in the first rounds of presenting this paper. So all the credits are for her. So and we think that this is not only important for the news industry, but also in other fast-moving industries like finance, search, online retail, and so on. And it's really an interesting way to think about sort of what is the role of data in creating competitive advantages. And so the way we do this here is we are making use of a natural experiment that happened in our field experiment, which was quite fun. I mean, for us, not so much for the data science team. So what they did is they hard-coded the year for when the algorithm was fetching updates of the personalized data. And then over the change of the year from so our experiment runs from December 17 to April 18. Then this created a problem. And of course, they were on Christmas holidays. And it's a very small data science team. So it's a big newspaper, but the people that care about that particular experiment, there's just a few, and all of them were on vacation. And so only when they got back on January 6th, they realized that actually the data was not updating because it was still trying to pull data from December 2017. And the data from December 2017 didn't exist. So the algorithm would just not update the data. And so it would keep producing recommendations, but based on the most recent data that it has. So it's as if your preferences didn't change for six days, which is a lot of time in the news cycle. Although, of course, the first week of January is usually a rather slow news time, but anyway, so that's how we like to interpret this. And so it gives us a way to look at this question of stock versus flow, because we're going to have variation in the stock, because just as the picture we just looked at, some users will have a greater stock because they already came back more often, and then some users are more active, so the speed with which they come back differs. But now the algorithm is limited to only using the old data, and so over time the recommendations will be based on more and more outdated data. And so this is what you're seeing here in this table is we're various way of implementing this. So this is basically just a dummy that is one for the first week of January 18, and you see that the treatment effect becomes significantly worse. So people click less. Then you can sort of, when you want to think about the dynamics of this, so in the January 1st, the recommendations should still be better than on January 6th, because it sort of keeps on being more and more outdated. So the way we do this is just a simple time trend. You see that it's increasing. Sort of the negative effect is becoming worse and worse as we progress in that week. And then this is the amount of visits. That's the stock part. And so for that's only in the bug period, so only in the first week of January, where we have established that that this New Year bug, sort of the lack of updating, really affects the treatment negatively. We're looking at people that have come back more often, so have a higher stock of data. And you see that here this sort of puts the treatment effect into the other direction. So you can sort of, for some users about which you already know quite a bit, it's not as bad if you do not update the data very often. Okay.
So, Christian?
Yes.
I think this is quite minor, but strictly speaking, the model 1 at least, or model 2 too, is not, you can't differentiate between the time varying treatment effect, right? If it happened to be that week for some reason, okay, never mind. I think it's reasonably minor.
Yeah. So yes. So anything. So we do have the day fixed effects still in there, and so if there are things, news events, if it's just a boring week, then that might capture the boring week effect. But then we also have, can control for the fact that some days might have different news stories. But yeah. So that's a problem to some extent, but then also, remember that we're comparing there's also the experimental variation still in there. So it's conditional on it being a boring week. We still have some users in the treatment group and some in the control group. So some see the human curated version, and then others see the personalized recommendations. So that should alleviate some of those concerns. All right, so let me talk about research question 2, which was, now that we've established the sort of the returns to data, let's look at different types of data. This underperformance that I showed you in my graph, where it was you had these negative treatment effects. One way to think about this would be, is this just because of limited data? Is this what they call in computer science in this literature a cold start problem? There's just not enough data, if you were to fix this, put a different algorithm, then that would be easy to fix. But essentially, our algorithm already is designed to do that, because we are also using the aggregate data. We have a combination of personal data and aggregate data, and so even for the people that about which the algorithm doesn't know too much, there's still this aggregate trend that what other people are looking at should also be part of it. And so the question then is, why is aggregate data seemingly useless in mitigating this potential cold start problem? And we think that the answer is that user heterogeneity is just important. And the way we go about this is we come up with a measure of a cross-user heterogeneity, which is the cosine distance, or basically the idea is that we're looking at sort of people's preferences and measuring how far are you from kind of like the average preferences in terms of your clicking behavior, of course. And this is where we are looking at clicking behavior before the actual experiment. So everything I show you now is based on a subsample of users that we already observed in November 2017, before the entire experiment happened, such that we sort of are not dealing with the problem that the algorithm might push people down a specific rabbit hole in terms of the categories that they're looking at. Okay, so same picture as before. Now just two lines. So we're looking at people that have a particularly low distance. So you can think of these as the people with mainstream preferences. They have a low distance to kind of like the average preferences. And then in red, these are the niche guys that have a high distance from the average user. And you see that users that are closer to the average react stronger to these algorithmic recommendations. So for them, there's actually no significant difference, even if there's not a lot of personal data. So here it really helps to have this aggregate information in there, because they are like the aggregate to some extent, and so there's no difference between the human curated version and the recommendation algorithm. And then once you have more personal data, then you see it the positive effect kicking in.
Okay, I can't resist asking, you know, particularly since you can reverse this with a little more personal data, what is it that you find, you know, who is it and what do you find out about them that lets you be able to do this? What, do you know?
So, yeah, I mean, so there's still a lot of users, so it's so I don't, you know, I don't have a very detailed answer to this, but it's mostly you know, this is this consumption measures is across categories, and so most people actually look at politics news, and I think sports is the second most popular category, and then these sort of the more these high distance guys, they tend to be users that are also interested in in categories that are not politics and not sports. I don't know if that answers your question, but these are, like, you know, people that spend more time reading the news and are interested in more different things.
Yeah, well, by definition, they're interested in the less popular things, but
yeah.
but they're more eccentric in some respect. Yeah. It's just it's funny. You know, I'm trying to think of the way the computer science people talk about edge cases, that the edge case here can eventually be documented enough that you can bring them into a prediction. Right, that's what's interesting here.
Yeah, so yeah, I think so. What we're showing here, this could be easily fixed if you had the chance to change the algorithm. Yeah, that's a super easy fix, and I'm sure that somewhere in the computer science literature they have thought about this already, and it's just not being applied yet in these kinds of real life settings.
Yeah, because the bang for buck is quite high here for those. Yeah. For that particular class of users. Yeah.
Yeah.
Yeah. Okay.
All right. So now let's talk a little bit, and I'm looking at the time. So let's talk a little bit about network effects. So this idea that, you know, as you have more users, these more users generate more data, which you know, leads to innovation because you can learn from that data, which then attracts more users and so on. That's the general story about data network effects. And so the question here is really, does a larger user base lead to better algorithmic performance in our setting? And so the way we can do that is by zooming in on a sample where the algorithm mainly uses information from other users, like aggregate data, and then estimate the treatment effect conditional on the lagged number of users, sort of making use of the fact that, you know, there are some less interesting news days where less people come to the website, and there are more interesting news days where more people come to the website. And then over time, we'll have some variation in, you know, what is the sample size that the algorithm uses in order to make these aggregate recommendations. And of course, this is slightly less causal, because there's no experimental variation, no quasi-experimental variation. We're relying on the fact that, you know, exogenously some news days are different than others. So this is probably the sort of the part of the paper where, you know, I'm less confident about the actual causal claims that we can make. We played around with all, you know, the usual stuff that people do with instruments and so on, try to instrument rainfall with news reading behavior and so on, get basically the same stuff. But anyway, so what is this, the part of the sample that we're zooming in where it's mostly the aggregate data that is used for the recommendations? That's this part here, where there's not a lot of personal data. And so what I'm going to show you is basically this area. We're only looking at users that have less than 6 visits. And then we are sort of comparing their treatment effects across time. And so some users would be on days where there's less users overall on the web page, and then the treatment effect where there's more on days where there's more users. And you see there's quite some variation, right? So this is in thousands. So some days see less than 500,000 users, and others closer to 1 million users. So there's really quite some variation. And again, blue and red, these are our different types of users. The red ones are the kind of like the niche users, and the blue one are the mainstream ones. And you see that for the mainstream users, as we looking at days where sort of the platform is bigger, versus days where the platform is smaller, there's less of a user base, the treatment effect basically doesn't change much. But for these mainstream guys, you see that as you add more users, as the platform sort of, if we want to interpret it in this way, as the platform grows, you'll also see the treatment effect growing. So adding more users, having a bigger user base sort of helps you to make these predictions that are based on aggregate data.
Christian, I would have expected the opposite. So I would have expected that actually scale is extremely beneficial for these niche users, for which you're basically filling the characteristic space. So you're much more likely to get somebody who's similar to me if I'm a niche user when there's 700,000 users than when there are 400,000. And so I would have assumed that the red line would be sloping upwards and the blue line would be flat.
Yeah, so I see that where you're coming from. So and I think what you're doing implicitly is assuming that sort of the composition, the distribution of preferences is the same with these 400K users and these 750K users. And if that's true, then I can see the mechanism that you're proposing. Maybe why we're not seeing it.
But that's sort of an exogenous increase in the size of the users, right? Like, because if you are increasing the size of users, but you're also changing the composition of those users, then it's not really a clean.
Yeah, that's why I say I'm less confident about the causality of this stuff here, because it could just mean that, on a boring, so let's say this is a boring news day, and this is a very exciting news day, that you get a different type of crowd coming to the website.
Yeah.
And so and that might be driving it. So actually, what we should look at on the x-axis here would be users per type, high distance guys and the number of high distance guys, and low distance guys and the number of low distance guys, something like that.
Yeah. So users of my type on the x-axis.
Yeah.
That's a good
and
point.
Then we would probably see, for both of them, I don't know what to expect, but probably we would see an increase for both types, because as there's more people like you.
Yeah, because it's just very surprising that, the low distance guys have these very strong linear relationship and increasing in a linear fashion, when you showed us that everything else has sort of decreasing marginal returns or even flat returns. So it's a bit surprising, because these are the guys you should have been able to guess even with very few data points. Even to some extent, even the human knew what these guys wanted.
Yeah. So yeah. So yes, I see your point. So but still, I mean, when you add more users, you also get more. You're much more likely to get the average guys. This is 10% of the sample, but of course they are much more representative of the average, because they have the closest distance to the average, whereas these are really more extreme guys. These are the most far from the average guys. And so as you add more users, you're also sort of you're getting more data points on what's the average taste. And if the average taste also is, if it's fairly difficult to predict, and this changes also a lot over different news days, then I guess you could still see this linearly increasing trend. But that is definitely, it's a very good point, and we should look more deeply into this.
Christian?
Yes, Hong.
Christian? Okay, my question totally, I realize, is because I sort of got distracted for maybe 5 minutes somewhere before when we were introducing this. So at first I thought the low distance, was within person, in the sense that Shane is sort of a general interest guy, such that within him, he consumes the politics, geography, and history, and all sorts of things, right? But I am just so boring. I only like reading novels, like particular kind of romance novels. And I'm like a low distance within myself. I thought, at first I thought that was the way you separate these users. So then people like me are extremely predictable, but Shane is probably sort of predictable in a way, but like if he's his data probably harder to fill in that sense. But then I realized that you actually sort of segment them based on aggregate speaking, like whether somebody is closer to the mainstream user versus further away. So I'm just wondering, like, whether my mistakenly understood way of cutting is potentially interesting.
Yeah. So yes. So here this is across, and in the next couple of slides I'll talk about within user diversity, reading behavior diversity.
Okay.
So we actually looked at all combinations, and then here for some reason we decided that here we want to look at the across categorization of different user types, because it just felt more natural to us in this whole debate of the data network effects to look at across user learning. And sort of chose not to report the within stuff also in that setting, but we've also looked at it, and you basically get similar things.
No, but like but I was actually thinking that it's more useful in the sense that niche users that have very predictable taste, then having more data point in that particular niche, but even though it's far away from mainstream, it's going to be extremely useful.
Yes.
Anyhow, so wait.
Yeah. So I'm taking notes. So we can definitely add back these results. Thanks, Hong.
Yeah, Christian, may I say something? Hi.
Yeah, of course. Please. Hi.
All right. My name is Lausanne, and I'm also like looking on to similar problems, and I'm really interested in what you find here. I think it would be interesting if you control for the degree that these personalizations happen, like the number of groups, for example, that these algorithms target. And the reason I'm saying this is because probably that's like I had a dynamic model for these things, and I was like playing with it, and I think there will be some sort of like marginalization effect. So the more users you get, those people who are in the marginalized community becomes even marginalized more. It's like it's a spiral down effect. So that's a part of the things that's happening. That's why you have like a negative slope on the high distance user, I think. So those who are underrepresented will become even more underrepresented by the degree of personalization.
I think that's a very interesting way to think about the downward slope. We actually,
Go ahead.
So sorry. Go ahead.
No, go ahead. So the reason I was like in my model, I was like thinking that look, let's say that we produce one recommendation for everybody, like for everyone. Then the higher represented group benefits well from it, but those groups who are like in a distance from the average, those are the ones that become marginalized like super far, and then they probably like abandon. If you have two groups, then or three groups, and then as like a number of personalization groups like increase, then it becomes like the negative slope becomes like steeper and steeper and probably goes higher. It's kind of not like what we have for society and stuff. Like if you have a society of 90% believing one thing, that then 10% becomes like far away from the produced results. So degree of personalization really matters here, and that's like part of the research that I'm doing now. So I was like, I'm really interested in like seeing if you can get the degree of personalization from those guys, and then like include it in your model and see like how it works.
Yes. So let me push back on that question, because
Sure, yes.
I think I might have slightly more to say about this when I show you the next couple of results, where we actually look into the within user consumption diversity. But I really like your question, because it sort of helps us to connect these two things a little bit more closely. And we haven't spent too much time thinking about why this would downward slope, because we like to interpret it as, it's not a big deal compared to, how much this other thing is increasing. But, let me talk about the consumption diversity effects in the last, how much time do I have? 4 minutes. The question that we ask here is, how do recommendations affect consumption diversity? Here we look at the like a concentration measure, so the HHI of consumption shares across topics within users over the entire experimental period. And what we do is we again make use of the fact that we observe the same users, sometimes in a control group and sometimes in a treatment group. And then we compute the HHI for whenever this user is in the treatment group and whenever they are in a control group. And then we are basically looking at sort of are there differences between treatment and control group within these users? And so this is what you get is that sort of looking at the concentration clicks when people click only on slot number 4, the treatment slot, you see that the concentration increases. So the if I want to use the diversity word, then the diversity decreases, and then depending on the users HHI, sort of their consumption diversity before the experiment, we can see that this happens even more for people that were already quite not so diverse, quite concentrated in their reading behavior before the experiment started. So people who are already in the rabbit hole, they get pushed further down into the rabbit hole. All right, and this is the last slide that I want to show. This is sort of looking at this dynamically. Again, as we're as the users come back more often and the algorithm gets more data about them, you'll also see that their within user concentration increases, meaning that the diversity actually decreases. So that's the rabbit hole picture. Esan, you tell me whether this sort of in some shape or form addresses your question. I think it does in some sense, because I think with these results we can speak to the point that some people might actually be they're served according to their preferences, and then at the same time, according to their preferences, would mean that they sort of get pushed away from the mainstream. And in that sense, I think that it's related to what you're saying. Okay, so let me conclude here. I have 2 more minutes. We find that human judgment complements automated algorithms, and personal data helps prediction, but there are these diminishing returns that set in quickly. We think that this has quite interesting policy implications. First, for a debate about privacy, where it's not so clear whether sort of restricting firms' access to personal data is actually in the interest of users. If we can interpret them clicking more as revealed preferences, and then of course there are the managerial implications that we talked about when I showed my back of the envelope calculation. Then the suggestive evidence in line with this, what we call the local data network effects, where it matters sort of where the composition of users and their preferences matters in how much you can actually learn from additional users and their data. And lastly, the last thing that I showed about the filter bubbles and rabbit holes and so on. Well, thanks so much for all your comments and questions.
That was a
very helpful.
Terrific presentation, very rich. My goodness, you really mined that data for a lot of interesting insights. I really appreciate you taking the time to explain it to us. And the survivors, those of us who are still here, let's give them a round of applause.
Yep.
Yeah.
Great paper.
Yeah. Really.
Thanks so much. Thanks for surviving.
Yeah. Yeah. Yeah, that's what happens. God, that was terrific. Really interesting. It's I wonder if the newspaper will ever let you do something dramatic.
Yeah. So what they as I mentioned, they ran a couple of extra experiments. And
you know their results?
No, because the reason why we got in touch with them was that my friend who was in my PhD cohort, he was heading the data science team at the time.
Wow.
And now he moved on to a different company. And so now it's much more difficult to get them to cooperate and even respond to emails because all the social capital is gone now. And we just
got
know
this
that
one project out.
Yes, so we know that they're running the experiments, and we kept on pushing them to give us the data. But it's very, and then of course there's COVID. People they have different things to worry about than these fun side projects that are not even fun for them.
What a very funny accidental experiment in the first week of January.
Yeah.
No, not by design, but nonetheless, I appreciate your creativity in using it. But on the other hand, I can imagine your first reaction when you heard about it was, "Oh my God!" And then you realize,
yeah, exactly. It was like, "Oh no, they screwed up. What is going to happen to our paper?" And then it was like, actually, that's cool. We have a natural experiment in a field experiment.